Okay, sir.
A very good evening all. Welcome to this wonderful session on behalf of Government College of Engineering, Thanjavur in association with Pantech e-learning. I hope everyone will be fine. Myself, Srinivaslu Hala, I completed my MTech in Power Systems. Today the session we discussed about renewable energy with MATLAB. So on Pantech profile, if you observe, our company established in 2004. We have 7 branches and more than 100 employees. We already conducted more than 200 workshops, and we give our knowledge almost 85,000 students, and our portfolio R&D for industry projects, faculty development programs, hands-on training workshops, internships in plant trainings, short-term courses, value-added courses, academic project training from Pro8, customized design service, and state-of-the-art R&D. The domains which we are working on: Internet of Things, artificial intelligence, embedded systems, robotics, VLSI, FPGA, TMS process, image processing, OpenCV, network simulation, power electronics and electrical vehicle, big data, data analytics, Internet of Things, Python, Android application development, data, image and text mining, cloud computing and mobile computing. In these areas, our employees and we are working and we are trying to give our best to the customers. In this session, renewable energy systems. So before going to discuss about the renewable energy systems, what are the contents here we discussed? Introduction, solar energy, wind energy and hydropower, biomass energy, geothermal energy, wave and tidal energy. These all energies comes under renewable energy system, which are not exhausted. These are all free from nature itself. Free of cost we are getting. So before that, what energy we are using? So if you observe here, all the renewable energy sources are principally derived from the enormous power of sun's irradiation, either wood or wave or solar or wind and hydro. So all these things we are getting from the nature with free of cost only. So how much effectively we are utilizing those resources? We need to question ourselves how much effectively we are utilizing those sources in our daily life, whether we are properly using or not, which energy sources we are preferring now. So these renewable energy sources are at once the most ancient and now also. From origin of man or human life, from the ancient, our forefathers, ancient people, before Christ, before Christ and after Christ also, we are using these renewable energy sources. So if you observe the modern forms of energy used by changing some technology, we are implemented in some technology, from that we are getting the energy source, we are survive ourselves. So solar power is one of the ultimate sources of energy upon which early human societies were based on. So if you observe the ancient temples and the ancient pyramids, if you observe anything from there only, we are getting the sunlight. Through that energy, when the people are started to live their daily lives, in their daily life they are living from based on the architecture. If you can remember easily, through that architecture, when the sunlight is fallen, then there it is reflected and the people will get some brightness and they are living and their daily lives, whatever the food and goods also they will prepare through the sunlight. Initial stage we are through the stones only we are rapid that fire, right? So day by day the technology growing, industrial civilization happened. At that time the people are changed. So initial stage we are getting the power by seeing this architecture. You can get an idea clearly how the humans are lived in the ancient days. So daily life, when our ancestors first used fire, harnessing power of photosynthesis, which is solar driven process only. If you observe these two figures, you can get a clear idea. Basic photosynthesis. Basic photosynthesis, they were harnessing the power of photosynthesis, which is a solar driven process only, by which plants are created from water and the atmospheric carbon dioxide they are creating, they are living, they want to feed themselves, right? So they are creating the fire due to the atmosphere through. So scientists went to develop ways of interesting the movements of water and wind to grind corn, irrigate crops and propel ships. How to run the propel ships? If you observe the before ancient days also, we are traveling on the ships. At the time, how they are traveling through the through woods only, right? Through woods they are created some wind power, they will generate the power. Initial stage in United States of America, they are generating the power from wood power plants only. Up to 1932 they were most of the rural area people, they are depend upon wind energy sources only. But it will, to maintain that wind energy, it is somewhat burden to that rural area people. So when they invented fossil fuels, through that fossil fuels we will get more energy sources and the people are changed for that power. So both the natural movements of water and wind are caused by solar heating of the oceans and the atmosphere also. So by observing this figure, you will get one idea. Water and wind are caused by the solar heating of the oceans and the atmosphere. So how civilization becomes are more sophisticated. Architects began to design buildings to take advantage of the sun's energy by enhancing their natural use of its heat and light. So reducing the need for artificial sources of warmth and illumination, the technology is growing, and day by day they are implemented on renewable energy sources only. They are implemented, they want to use more and more solar energy power. The technology before initial stage, how the people are harnessing the power of sun, water and wind, continue the power right up in the earlier days, industrial revolution, when it becomes in the mid centuries, when the industrial revolution happened. At the time, the coal, advantage of coal and fossil fuels exploited at large scales. When the people are realized themselves through the coal from the fossil fuels, whatever the fossil fuels, natural gas, uranium, petroleum, diesel, all the fossil fuels, we now the most of the world depends upon the fossil fuel energy. When the people are more on industrialization, they are moving on to fossil fuels only, then they are neglected the renewable energy sources power. But initial stage they are depending upon, they know the only energy sources from renewable energy sources only, so they are utilizing that power. But when the industrialization happened, at the time the coal and whatever the fossil fuels, through that fossil fuels we can generate more and more power. Through that power we can drive ourselves in a better way, they are thinking. And here, when you want to drive the train also, when you want to run a plant, either it is a thermal power plant or any power plant, if you want to run, means they are using the coal most of the cases. Initial stage we have coal trains, right? So through that coal train, these highly concentrated energy sources has soon displaced wood and wind. Through that fossil fuels, they are implemented in drives, trains, technology, they are implemented. Through the thermal power plant, they are trying to generate more and more power. But what happened? By using the fossil fuels and those energy sources which are getting from earth only, but what happened after generating the more and more power by using the fossil, what will happen? Air pollution will become more, right? It will be affected on human life. Not only human lives, it will be affected on more and more creatures of the nature. So today the fossil fuel tree of coal or natural gas and oil provide over the 80%. As per IEEE standards, in all over the world, 86% of the power will be generated from these fossil fuels only. But remaining power we are getting from renewable energy sources and new plants only. So then what? For their reports, as per the IEEE reports, within the 150 years, all these fossil fuels, whatever we are using now, 86% of the power, almost 80%, but as per the IEEE report, they are saying 86% of the power we are generating from the conventional energy sources. Through the conventional energy, so we are depending upon when it will be evaporated. These energy sources are not created, right? These, if suppose if we take from oil, petroleum, natural gas, we are importing from the other countries. If it is evaporated on the earth itself, then how the world will be sustained? How the world will be sustained in this world after 150 years? So the researchers and the technocrats and all over the world thinking that we want to move renewable energy sources, and at the same time we want to use these conventional energy sources with an effective manner. With an high efficiency. If we can use these energy sources, means we can live another 100 years also. We can utilize this energy sources another 100 years also they are expecting. So what happened when we people only destroyed the nature, right? We are the reason to destroy the nature as a deforestation, or the creatures of the beauty of nature we are destroying. We are not giving a quality of the power, a quality of the air to the future generation people also. So we want to think, we want to shift renewable energy sources. Concerns of the adverse environmental and social consequences. The fossil, whenever you are using the fossil fuels, what happened? Air pollution, oil spills, mining projects. If you are implemented in sea, if you are implemented a mining project in sea, means what happened? The surrounding animals and the creatures of nature all are dead. By seeing the figures, you can get easily one idea. Deforestation, what happened? Deforestation, we are not getting proper air, right? We want to buy oxygen cylinders in the future generation. Now we are affecting Delhi, New Delhi, they are affecting, right? Even whenever winter season comes, at the time their oxygen cylinders are they are using. So we want to give that type of future to the future generation. Our future generation we won't give, right? So we want to save ourselves, and we want to give a clean and beauty of society to the future generation people. So what is a renewable energy sources? What is a renewable energy sources? Renewable energy sources include such as natural resources which can be replaced by natural ecological cycles. That is the way they renew, thus never gets depleted. Whatever geothermal energy, as per geographical construction, geothermal energy will more, they are getting more power from United States, the geographical, depending upon geographical construction. If you observe the European countries, all over the world, if you observe the European countries, their geographical structure is very different. As India geographical structure is different. So most of the European countries, they are working on wind energy system. That too off grid and on grid also. Off grid and on grid wind energy they are working because their geographical construction is different. As of consider geothermal energy, the people who are living in United States of America, they are using geothermal energy. So we are saying tidal, wave, geothermal, wind and solar energy are counted as renewable energy sources. So the energy coming from if you observe all these renewable energy sources which we are discussing, in these renewable energy sources, most of the power we are generating from two energy sources only. One is wind and solar. So these two energy sources which are comes from highly, it will not affect on the pollution. It is a free of cost all over the world, and it will be highly we can take if you generate the power means. So the passion, what is the passion we want to think? I do put my money, the famous quote by Thomas Alva Edison, He was the inventor of light and bulb. He was the one who introduced the power. So I do put my money on the sun and solar energy. What a source of power I will get. I hope we don't have to wait until oil and coal run out. So we don't want to wait. If so, if suppose as per 150 years all the conventional energy sources will be evaporated. So after, if you think after 150 years only, right, so no problem, now we can use more conventional energy sources, means I can run myself, I can run my children's life. Then what about the future generation? We want to think future and further the people, right? After 150 years also we want to think, we want to avoid the most of the fossil fuel energy source. We want to implement more energy source from the renewable energy sources only. What is a photovoltaic? Solar energy or photovoltaic energy, if you observe, if you put a solar panel on top of your home, if you observe, from you are getting from sunlight directly to your home, right? It's a free of cost. Once if you install a solar power plant on top of your home, you will get a free of cost. What will happen? Photovoltaic is, photo means light, voltaic, voltage will be generated from the photovoltaic. PV systems or photovoltaic systems use electronic component to convert the solar radiation into the electricity. Here what will be happen? Photovoltaic energy will be converted into the electrical energy. Greater the intensity of sunlight, greater is the flow of electricity. If you observe, we have winter season and summer season, right? And another rainy season also there. So depending upon the season wise, we will get more. If you have more sun power, you will get more, you can generate more electricity also. So how you will generate, which type of solar systems are there now? So history of PV effect, certain materials would produce small amount of electrical current when exposed to light. Is saying by Alexander in 1830. A silicon semiconductor was able to convert. So most of the solar panels will be made on silicon based cells only. Silicon semiconductor was able to convert the light into electricity with 4 to 6% of efficiency by Bell Labs. They are proved in 1954. So a silicon cell will be convert that light which we are getting from the sun into the electricity. So electricity generation through the PV. Solar panels we are from, if you observe here, the sunlight, when if you are putting the solar panels, from this solar panel the sunlight will be happen. Here based on the PN junction diode, N type semiconductor, P type semiconductor, through that we can generate the power from the solar panels. The sunlight will be, that sun intensity will be take here and it will be converted photovoltaic energy into electrical energy. They have the properties of an insulator, but when exposed to light or heat, they become a conductor. What are the advantages of electricity? Suppose why we need electricity, why we need solar renewable energy or solar power, means to reduce the electricity bills, right? So if you want to, if you put a solar power panel, if you generate, take an assumption, if you consider an 18.5 volt open circuit voltage and near to 20 open circuit voltage, 335 megawatt, 335 wattage solar panel, if you consider, so 18.5 open circuit voltage solar panel, it will give 335 watt, right? So how much wattage of power you are consuming per month? If you observe your electricity bill at your home level, how much power you are consuming per month? At least if you are in rural area, near to 200 units, right? If you are in urban areas means 200 to 300 units. Suppose if you are in cities, 300 to maximum 500 units you are consuming per month, right? 500 units you are consuming. So one solar panel 18.6 open circuit voltage, it will give 335 watts. Suppose when you want to install a 1 kilowatt solar panel on your home, how much solar panels you need? 3 solar panels you need. then that the three solar panels daily, if you install on top of your home, it will give daily 4 units only. It will give 18.6 open circuit voltage, 335 watt solar panels. If you want to improve the voltage levels, means you want to connect in series manner, right? So when you connected in series, then you will increase the voltage levels. Voltage improvement will be done. So 1 kilowatt solar panel, you need 3 solar panels. You are connecting in a series manner. Then you are getting 4 units only. So 30 days, how many units you will get? 120 units only, right? So if one bulb and one fan at your home means that amount of power is sufficient. Now everyone feeling luxury, right? Everyone adopted the luxury life. Everyone have ACs. Everyone have TVs. All the people, their technology growing, right, day by day. So we are consuming more power. Suppose if you need 200 to 300 units, means how much 3 kilowatt solar panel make? If you put 3 kilowatt solar panel, means how much power you will generate? 12 units per day you will get. 12 units you will get means 30 days 360 units. So it is sufficient power, right? So that 3 kilowatt solar panel in real time, if you install on top of your home, means it will nearly cost 1,50,000. If you are installed that 3 kilowatt solar panel on top of your home, means it will be cost, the total cost is near to 1,50,000. But the governments and the Indian government, they are providing some subsidy also for some governments, Madhya Pradesh or Kerala or Telangana. That governments, they are proposing 40% subsidy those who are installing the solar panel. So if you are installed 360 means, so when you do how much, if you suppose if you turn on all the loads at your home application also, you will, how much power you will consume? For average 8 units if you take. Average per day you are consuming 8 units. Then what will happen? 240 units only, right? 240 means how much power, excess power you have? How much excess power? Near to 120 units you have. So if you connected that power, if you connected to grid, that is a on-grid system. If you connected your solar home install, you are installing, if you connected grid system, grid distribution systems, they will give the money for that 120 units also. So in solar PV systems, we have two type of solar PV systems have. One is centralized PV system, another one is decentralized PV system. Centralized means if you take 100 acres, Adani Group, they are trying to implement, Adani Group, big companies, they are invested the money onto a solar park, like a solar park. So 100 megawatt or 60 megawatt or 300 megawatt power plant, if they install, means it is a mini power plant, thermal, like a thermal power plant. They are generating the power at one particular point, centralized system. They are generating that power. After generation of that power, they are transmitting the power through transmission lines. If you observe here, through the electrical transmission systems, they are generating. If you observe here, what will happen if you are generating the power through transmission line? Transmission lines will be, transmission losses will be, some power losses will be there. So when you want to that power, if you reach the consumers, here the consumers are there. From here to here, the distance, if you consider, it is a 30-kilometer distance. So you want to put a 30-kilometer transmission lines now. So whenever you are installed a centralized PV system, what are the problems will come? So if you are connected these solar panels, if you connected these solar panels in a series manner and parallel, what are the problems will happen? So if you are installed a centralized PV system, 100 acres means, so the irradiation temperature, all the solar panels will get same. It will not get, right? Those solar panels will not get same irradiation temperature. Because for assumption, if you take the 25 degree, from morning onwards, evening, we have vary the temperature and atmospheric conditions are varying. Then how you will get the exact power? You will not get, right? So what are the problems we'll face at centralized PV system? Voltage mismatching problem will happen. Suppose in this solar panel the temperature is somewhat the irradiation temperature which is tracking from the sunlight. Here the high amount of irradiation rays are it is tracking, then it is generating maximum power. What will happen? Because it is a 100 acres land, if you think 100 acres land, if you think means, then what about this one corner of, so corner side we are getting different irradiation temperatures. So voltage mismatching problem will be happen. Voltage mismatching problems will be there. So then if you connected the solar panels, number of solar panels, if you are connected in a series manner, shadow problem will be occurred. One panel to one panel, if you connected in series manner, shadow problem will be there. So to overcome those problems, so we want to prefer decentralized system. Power generation efficiency can be reduced by significantly under chargeable weather conditions. So it is a good thing only, like a thermal power plant or hydro power plant. If you are installed a solar park, big solar park means you are generating the power, but you want to think the losses also. When you get losses, suppose if a company, a big company, Reliance or Adani Group, they are facing so many losses. They are in the loss, so they need profit. Means what they will do? They will increase the power bill, right? Automatically, ultimately consumer only will affect. They will not affect. If they will get losses means they will increase the power tariff bills, though ultimately consumer will be suffer. So then the best thing is you want to change decentralized PV systems. So here if you observe in the Indian system, sources for electricity in India by installed capacity, 59% of the power in India we are getting from coal only. Coal thermal power plants only we are getting, and hydroelectricity we are getting from 17% only. And the renewable energy sources which we are using now, 12% energy sources only we are getting. So we want to improve these, we want to more concentrate on renewable energy system, because day by day when you are utilizing these sources, fossil fuel sources, these will be day by day decrease. But this will be until the earth will be there, the air will be free and the sunlight will be free. So free of cost only you are getting. You don't need to pay taxes. Like if you are purchasing the petroleum or diesel, you are paying the taxes, right? So you no need to pay the tax to the government. You are getting free of electricity when you are installing a solar PV system. How the decentralized? This was done in Madhya Pradesh government. They are trying to implement in decentralized system on top of the rooftop solar panels. So 162 or 8 solar panels, if depending upon the load and the customer, they are planning, they are working with the companies. So decentralized PV system. When you are decentralized means you know how much power bill you are paying per month. At the end of the month you know well how much power, how much bill I am paying. So like that, if you think, if you are installing 8 solar panels, it will be effectively. Solar energy systems provide direct benefits of local communities because they provide obvious economic and social benefits to their owners. For example, they can sell the excess power back to the grid and therefore elevating their electricity bill. This is a solar off-grid systems. These off-grid systems are independently of the grid but have batteries. If off-grid system, if you are not much interested, you are getting the excess power, right? So when you are storing that energy in the battery systems means you can use that power at night time. You can utilize that power at night time. When you are installed here, you are installing the top of the solar panel, you are generating the more power. Through that power, if you have excess power, you can store that energy here. You can store that energy in the batteries also, which can store. The systems usually consist of solar panels, battery, charge controller, a grid box, inverter mounting structure and balance of the systems also. Grid tied system. When you are interacting with, when you are generating the solar power and you are connected, you are getting the excess power now. Through that excess power, if you connected with grid, here, if you are connected with grid, it will allow to save more money with the solar panels through the battery efficiency rate, net metering plus lower equipment and installation costs. The utility grid is a virtual battery. It will be act as a virtual battery because the battery cost is very high. So if you are taking electricity bill, electricity has to spend in the real time. So what are the problems we discussed in the solar PV systems? We discussed some problem, voltage mismatching problems and shadow problems. We are not getting the continuous power supply here. So when you want to install a solar PV system, two types are there. One is in MPPT technique. Now, why we need MPPT technique? We want to give continuous power supply to the load. So that's the reason we are preferring maximum power point tracking. Maximum power point tracking is an algorithm that include in the charge controllers. So in the charge controllers, it will be included for extracting maximum available power from the PV module under certain conditions only. So through that solar panel, you will get maximum power means how you will get means through the MPPT controller only. So in that MPPT controller, we have P&O algorithm, perturb and observe algorithm, incremental conductance algorithm, fractional open circuit voltage algorithm, and for now the new trends are fuzzy logic controlling algorithm, artificial neural network algorithm, partial swarm optimization algorithm. By implementing these many types of algorithm, they will identify at what point we are getting the maximum power. They will identify at what point these algorithms will find at what location of the point in that solar panel we will get maximum allowable power. So these solar panels, when you want to real time, so they are preferring with silicon only. Most of the cases they are silicon based solar panels only. Most of the companies they are preferring. So when you want to design this solar panel in a real-time model, you want to develop a 2 kilowatt solar panel. How are you able to do that one? So these solar panels we can develop in MATLAB simply. Matrix laboratory. Initially, it is developed by a lecturer by Clive Moller in 1970s to help the students from the linear algebra. I think everyone will be know very well. So later further it was developed under MathWorks, founded in 1984. It is a software package. It can be used to perform the analysis and solve the mathematical and engineering problems. To solve any engineering problem, we can use MATLAB. Means it has a excellent programming features and graphics capability, easy to learn and flexible also. It has several toolboxes to solve specific. So when you want to design suppose when you want to design a 1 kilowatt, so what are the steps you want to? First you need to develop a model in the loop in the MATLAB. Model in the loop, if you design mean, you want to design that model in the loop in open loop and closed loop. So once you've done in the model in the loop, then you want to go with software in the loop. When you want to make a product, you want to make a solar converter or solar inverter, if you want to implement it, that one means you want to go with these 4 steps in real time. Model in the loop, you can design that model, you want to analyze through mathematically, and then you want to test that one, software in the loop. Then you want to test in a practical manner, hardware in the loop. For that one, if you are developing a solar inverter, for that inverter, you need compulsory to give the switching pulses, you need compulsory one processor. So that is called processor in the loop. So for that one, if you want to use DSP or FPGA or any new type of processor you can use, means it will give more effectively the solution. So simulating is to analyze and simulate dynamic systems by using the block diagrams only. So mill model in the loop we already discussed. So in these industrial applications, robotics, aircrafts, automotive industry, communication systems, data analytics, robotics design and control, financial engineering, image processing, to design a converter topology or inverter topology, you want to design a motor analysis, you can go with MATLAB, means it will give more effective solutions. And now here we will see we will see a basic simple model of MATLAB program we will see here. So this one is a solar MPPT boost converter. In this MPPT algorithm, this one is the MPPT algorithm. How we are designing here means by taking one condition. Here I am clicking from this solar converter. This is a boost converter, right? From this boost converter, how can go and how we are implementing this one means it's simple one at the basic level, and here we are taking radiation temperature 400 and the temperature is 25 degree. So this is a simple P and O type of algorithm. So by using this algorithm, when from the solar panel, initially you have a solar voltage and solar current, then you want to test that one where here change in voltage. By applying a memory block, it will act as a change in memory block, it will act as a delay. So change in voltage. Here we are considering Vn minus 1, change in voltage. From here, input voltage and input current we are taking from the solar panel. Then here change in current. This one change in current. From this change in voltage and change in current, we will get one change in power. Then from voltage and current, we will get one power, right? So through that power, we are getting here one output. From here, change in voltage, input voltage and change in voltage, we will get one. So delta P star delta V. Then we are connected to one if else condition based switch. So by connecting this switch, if suppose delta P star delta V greater than 0, then the switch will turn on. Here we are connected with one IGBT switch. In boost converter, we are using one IGBT device, right? So through that IGBT switches, we want to give the gate signal pulse. Here, by using this MPPT algorithm, we can give that means it will be convert that solar power into boost. It will boost up the output voltage. It will boost up the output voltage, and from here we are taking the repeating sequence. From the repeating sequence here we are taking the switching frequency we are taking here, we are taking 4 e power minus 4 and 0 to 1 output values taking. From here if you connect here, this one if we are connecting here, then at output of the switch 2 we are getting duty cycle. So for this duty cycle, DC-DC converter, when we want to turn on that duty cycle, normally 0 to 1 only. From here you will get how much duty cycle you are generating. Through that duty cycle, how much power will be converted at output side. So this is a, suppose if you connected this one, this is solar panel. In this solar panel, this is a two-stage conversion, because when you want to connect this one an inverter, means that is a two-stage conversion. In this solar panels, if you are implemented in real time, suppose this two-stage conversion type, if you go with here, the solar panels, you need less only. But if you want to remove this boost type of converter, so then you can directly give to inverter 3-phase voltage source inverter. If you connected means in grid connected system, then it will be converted. But in single stage conversion, the solar panels which we need less, we need more, because the requirement of power, the solar panel, it is that according to the load demand only it will be work. Suppose here in the solar panels, if you are placing a boost converter, what is the advantage means, if you are not getting the medium voltage also, if you are getting means you need to, there is a chance to boost up this output voltage. There is a chance to boost up the output voltage at loads. You want to reach the demand of load side means you can easily reachable. So here this is designed by some mathematical model analysis, the shunt current, reference temperature, and here this is all taking from function block, from the Simulink blocks only. From here library we are taking all these blocks and we are trying to design this one and connected. From here we are generating some power, and by connecting this one we will get here some output power. So we'll see here, this one we designed in 14 version. We will see here, this is a 2016 MATLAB version. It's compiling. So the only disadvantage of MATLAB is it will take so much time. So, and it is not a open source. It is not a open source. It is a licensed tool. So more than 6,500 universities and autonomous engineering college, they are working on MATLAB only, because by using the mathematical model analysis, numerical computation analysis, we can give the effective exact solution to that problem. So it is not a that much complicated language also. We have a number of inbuilt function. Through that inbuilt function, we can design any model. If you have a problem, if you have a equation model, means you can easily get the output solution. So it is running. Here we can go with fuzzy. Apart from P&O, incremental conductance algorithm, we can go with fuzzy and PSO algorithm, artificial neural network algorithm. By implementing that one, we can get the solution at exact point where we are tracking the maximum power. Here, why we need to place in this converter topology the capacitors and capacitors before the load we are placing the capacitors na. So these capacitors will help to reduce the ripple level voltage at output side, because we need to give the quality of the power. It will be disturbed when we are converting DC into DC also. It will be some distortions will be there. To minimizing those distortions, we want to place a capacitor. By placing the capacitor, capacitor will try to reduce those ripple voltages at output voltage side. You observe here, output voltage here. Here we are getting the output voltage. Near to here we are getting near to 350, above we are reaching the voltage, but distortions are somewhat little high. When we want to connect a grid converter topology, we want to give some modifications. And here if you observe the voltage and current, what how much output power, here the voltage current here we are getting at output side of the converter topology. We are getting, when we are getting high voltages, we want to get less current at output current. We will see here output current of the inverter converter is output current near to 0.75. So from this we will get the power is here. Near to 255, near to 300 watts we are generating from this solar panel. But when we are getting here, how much current here you are getting? This much you are giving if you are increasing the irradiation temperature here, you can improve the output side load voltages. And here the irradiation temperature we are taking from one temperature condition only, but in the real time it will be vary. 25 morning 9 or 10 a.m. it will be 25 minutes. When it comes to 12 p.m. the temperature conditions will become more, right? So according to the temperature conditions, whenever you are getting the low voltages from this solar panel, if you put this solar panel on your top of home or even top of your electrical car, if you put this type of solar panels, whenever these solar getting low voltages, by using this MPPT converter, this MPPT converter will help to give the maximum power point. Then this switch will convert the input voltage into high amount of boost of the output voltages. I hope everyone understand. For the next session we will see the wind energy. In the wind energy also we have offshore wind and onshore wind. Offshore winds, all the European countries they are preferring with offshore wind also. Why? Initial stage, when the wind plants are installed at United States of America, at one plant now we are seeing the PV now wind turbines we are seeing 3 only. But when initial stage, when we are designing with wood, when we are designing that wind plant with wood, at the time that have 144 blades. 144 blades have. So now by the changing the industrialization and technology, they are connected to one wind energy conversion. So through that offshore wind is there, onshore wind is there. In that wind plant, 3 blades only there. 3 blades are rotating by pitch angle. It will control that airflow will be controlled by pitch angle, because here whatever the problem we are facing in the solar, same problems will be get wind also, because this solar is also not continuous power, wind also not a continuous power supply. So simultaneously it will vary according to the wind flow is at night time it will be very high. Daytime solar power will be high. Daytime if you observe if you observe daytime, solar power we are getting more, but wind flow also we are getting less. But we consider at night time, wind speed is somewhat very high. So by combination of solar and wind, you create a one hybrid system also. Through that hybrid system, you can generate more power also. So initial stage when they are working on wood plants, so through that wood they are generating the power. At up to 1932 they are using that type of power only. But compared to solar, maintenance is the only the compared to solar and wind. Here solar maintenance is very low maintenance, but wind plant is somewhat difficult to maintain that one. So that wind power plant and wind energy system model in the MATLAB and Simulink based on by using the mathematical analysis, we will see a simple one. So thank you all. Thanks for the session, for attending and spending your valuable time on this occasion. I hope everyone will be safe, stay home, stay safe from Pantech Solutions and Government College of Engineering, Thanjavur. Thanks to college management and Pantech management. And once again, thank you all the participants. Subscribe our channel. We will update continuously. It will help. I hope you will get some knowledge by utilizing this time. Subscribe our channel. And thank you once more. Thank you all.
Start